Well, technical problems abound, but this presentation is very technically oriented, and despite our problems here in Natick, Piyush is going to tell you how amazingly things went up on Mars. Up on Mars? Over on Mars, I guess. So welcome to Coffee with a Purpose, and welcome, and forgive me if I don't get it quite right, Piyush Khopkar, who is a MathWorks employee and also a volunteer NASA educator and participant in the on the research work to be able to produce oxygen on Mars. The acronym for that project is called MOXIE, and Piyush is here to tell us all about it. Jianji and I had the pleasure of seeing Piyush in person at the community center several weeks back. And unfortunately, I think it was bad weather that day. There just weren't any other people there. But it's a fascinating presentation, and I knew this group would be really interested in hearing it. I think often we start with introductions, so Piyush kind of knows who we all are. I think that's more important when we're talking about like a local social justice cause. I think why don't we skip the introductions for now, and then as we get into conversations and questions and answers, feel free to elaborate on who you are. So with that, I'm gonna turn it over to you, Piyush. Thanks again for coming.
Yeah, thank you so much, Doug and everyone for having me here. I think it's an absolute pleasure. I've been living in Natick for almost like 8 years, and it's really excited to be part of this community and then share the work I've been doing so far over these years. So I will maybe like as Doug introduced me, I work at MathWorks as a full-time employee. I volunteer with the program NASA JPL runs, that's called Solar System Ambassadors Program. So it's a group of volunteers, like thousands of volunteers across the nation who share the excitement of space, the passion of space. Besides my work at MathWorks, I've been also contributing to the Mars 2020 and the MOXIE project for the last 7 years. MOXIE project ended back in September of last year because the goal that were decided or that was set for the MOXIE project were completed. So we are not actively working on the MOXIE project, but today I'm here to share like the whatever we have achieved so far for the MOXIE project. All right, so I will start sharing my screen. And we can make this, like talk interactive. So feel free to just interrupt me whenever you have any question, and then we can kind of have like more interactive session and conversation. Okay, so I'm going to start playing a recording. So unfortunately, because of some technical reasons, we couldn't get it, my audio shared. So everyone on Zoom, they might not hear the sound, but I have shared the link in the chat. So it's the same audio I'm going to play here. So feel free to listen to that audio while I'm playing it here. And
Cool. He'll actually explain more, but excuse me about that. No. Oh.
So what you're hearing this is a sound of a compressor on Mars. So as the audio progresses, the speed of the compressor changes. It was at lower speed, and then it went up to high speed, and then it would come up to a lower speed, and then eventually it turns off.
Are they going to become a leak blower?
Sorry.
I caught the joke, I don't know. You said, is it gonna sound as bad as leaf blowers sound here?
Oh.
Oh, so as I mentioned, like what you were hearing was a sound of a compressor on Mars. This compressor is aboard the Mars 2020 Perseverance rover, and it's housed inside an instrument called MOXIE. So again, like this is kind of a spoiler, but the MOXIE instrument made first ever oxygen on Mars on April 4th, sorry, April 20th, 2021. So this chart is a plot. This is a chart of like the start of the instrument, and then it made 5.37 grams of oxygen, and then that's the way the experiment was set up.
Give us a sense of how much 5 grams is, how long can that keep somebody alive?
So I think it's enough to keep a dog alive for a few minutes. Yeah.
So it's a start.
It's a start, but again, like I'll be talking about like what the goal, what is the main purpose of MOXIE instrument in my later slide, but and then I'll speak to that as well. So as Doug mentioned, my name is Piyush Khopkar. I'm here to talk about an instrument called MOXIE. MOXIE stands for Mars Oxygen ISRU Experiment. So we'll quickly go over like the overview of the Mars 2020 mission, what its goals are, and then we'll jump right onto our topic, which is MOXIE. How does it work? How does it like to operate an instrument on Mars? And then I'll go over a few of the MOXIE runs, and then like we will have an interactive session for people to talk and deliver those having questions. So there have been like a lot of Mars exploration missions in the past decade. We had orbiters, we had different landers, and the goal of every Mars mission was to basically learn from each other, and then like kind of build that knowledge so that we can, whatever knowledge we have built, we can kind of explore more on top of that. So as I mentioned, like past Mars missions have followed the water, built on each other's knowledge and discoveries. We know that there is plenty of evidence that water flowed on Mars in the past. And we also know that the planet was wet and habitable. And Mars had all the like basic building blocks of life, which still exist on the surface today. So we believe that the left image, what you're saying, that maybe Mars might have looked something like that, and then this is how on the right side it looks, I think, present. So we want to, with the Mars 2020 mission, we want to really answer, did Mars ever have life? So goals of the Mars 2020 mission, it's kind of divided into 2 parts. Like one is the ancient microbial life. So within the ancient microbial life, there are 3 goals: geology, astrobiology, and sample caching. And then the second part is prepare for humans. I'll quickly talk about sample caching as well. So this is the first mission. This is the first robotic Mars mission where we collected the sample, and the samples are basically put in a tube. And then the idea is to drop the tubes on the surface of Mars, and then next Mars sample return mission will be there, who will basically like bring the samples back here on Earth. On the prepare for humans, so again, like for prepare for humans, there are 2 goals. MOXIE is one of the technology demonstration for preparing for humans, because when we want to go, the idea of this goal is like when humans are on Mars, like how can we like prepare? So one, this rover had 2 technology demonstration. One is the MOXIE instrument, and the second one was helicopter, which is called the Ingenuity helicopter.
How big were the caches samples?
I think I exactly don't know like the length, like like the dimension, but I think it would be something like this, like yeah.
Couple grams.
Yeah, yeah. Couple grams, yeah. So the rover landed at a location called Jezero Crater. This was on the left side. This was the landing ellipse. And this is how the Jezero crater from like this image is taken from one of the orbiters, and this is how it looks like. So now we are going to jump right on MOXIE. So the idea with MOXIE is in few years from now, as I think that maybe we'll be sending people to Mars. Let's see. And the idea is not just sending people to Mars, but bring them home as well, because no one really want to one way trip to Mars. So, the problem, we like while sending for sending people to Mars, like the biggest challenge is how do they come back? Because sending propellant to Mars is extremely expensive. This is like just one small kind of data to give you a perspective of how it's going to be. So MAV here stands for the Mars Ascent Vehicle. So let's say it's a crew of 4, and then the mass will be 40,000 kgs. Liquid oxygen will be approximately 22,000 kgs. So 1 kg on Mars will be $45,000. So what we are talking about is cost to send one liquid, basically like the liquid oxygen for one MAV, which is the Mars Ascent Vehicle, for a crew of 4 people. It will cost approximately around 1 billion just for sending oxygen. We are not talking about any other thing else here. So, and why do you think why need that? Because when we are coming back, what we don't really realize is when we hear like when we have rocket, right? So when we ignite a fuel, we are basically burning oxygen because oxygen is there as an oxidizer. And when we are coming back from Mars, we will need that oxidizer, because where would that oxidizer would come from? So that's where we are talking about like bringing, basically sending liquid oxygen to Mars. So one approach to solve this problem is the Martian atmosphere has approximately 98% carbon dioxide. So why don't we try to take that carbon dioxide and split that into oxygen, and then store that, and then use that the stored oxygen as an oxidizer. Okay, so that's where the concept of MOXIE comes into picture. MOXIE stands for Mars Oxygen ISRU Experiment. ISRU stands for in situ resource utilization. In a very simpler term, in situ resource utilization means basically, like you are creating a resource out of another resource. So an example could be, let's say, you went for camping and then you forget to take the wood. So what do? You just like hunt for wood, and then you kind of create a bonfire. So again, MOXIE is just as I mentioned earlier, it's a technology demonstration for ISRU validation, because in the lab it works based on the experiments, but then doing something in the lab is slightly different than trying that thing real for the real on the surface of the another planet.
What does MAV stand for again?
Uh,
MAV.
MAV?
MAV,
Yeah, it's Mars Ascent Vehicle. So like the vehicle basically
Yeah.
that could bring
And then
the astronauts
okay.
back to Earth. So there are a few goals of the MOXIE project, or the MOXIE project. Like one is verify and validate ISRU technology, specifically on Mars. Learn the design approaches so that we can design a full-scale ISRU based on the learnings of MOXIE. Goal was set to produce around 6 grams per hour of oxygen. Produce oxygen with 98% purity, and then run at least 10 times in 1 Martian year. So 1 Mars year is equivalent to 2 Earth years.
When you say run,
Is that 24/7 or is that for 1 hour?
Yeah, so we don't run MOXIE, we did not run MOXIE 24/7. I'll get on that, like why, what is the reason behind that? But then by run means, like so as on this slide, so this is like the schematic or the picture of the MOXIE instrument. So there are three main parts to it, like motor, the scroll compressor, and the right here is the solid oxide electrolysis. So this is kind of the heart of MOXIE instrument, which kind of does the chemical reaction. And then on the left side, you see like this is basically it's about the size of a car size battery. It weighs around like 37 pounds or 14.14 pounds on mass. The power required to run this instrument is 300 watts. Oxygen production rate is 10 grams per hour, and then operation time is approximately 4 hours. So when I mentioned run, so one run was of the MOXIE instrument was approximately 4 hours. Did that answer your question?
Yes.
Okay. So how did it work? So the idea is MOXIE first heats up this oxy. So SOXY, as I mentioned, it's the heart of the instrument. It contains the cells which performs the chemical reaction. So the idea was to heat up this oxy at 800 degrees Celsius. And then after the temperature reached to 800 degrees Celsius, it collected the thin carbon dioxide. It had a filter outside the rover. And then once the carbon dioxide is being collected in the instrument, then it is compressed using a scroll pump, and then pass the compressed carbon dioxide to SOXY to produce oxygen. It's pretty simple, you know. So I think I have a few pictures.
So you.
Yeah.
So the main challenge here is like heating something up to 800 degrees Celsius, because when we're talking about heating something up to 800 degrees Celsius, it had so MOXIE is basically housed inside the rover. It had like its other instruments as well. So this is where MOXIE is placed inside the rover. So now if you look, there are all these instruments. So when we are thinking about like heating something to 800 degrees Celsius, we also need to make sure that we are not burning anything else in the belly of the rover.
800
Yeah.
degrees Celsius is pretty hot.
And the reason it did not run for 24/7, because again, for heating something up to 800 degrees Celsius, so basically the rover is powered by, it has a battery, but the battery was charged by the radioactive element, the decay of the radioactive element. So whenever we used to run MOXIE, we couldn't like no other instrument could really run, because MOXIE itself just consumed most of the power of the battery. So because, and again, like because this was a technology demonstration, so we did not really run it, we did not really needed to run it for 24/7 either. So we then used to plan the runs, and then that's when I mentioned earlier that the goal was to do at least 10 runs in one Martian year. This is the MOXIE inlet filter assembly. So the idea was as I mentioned, so Mars has 97% carbon dioxide, but then there are other gases as well, and we really did not want those gases. So the idea was to filter the air we were sucking in, passing into the carbon dioxide, the MOXIE instrument, and kind of we want to make sure that we were getting as pure as carbon dioxide we could. Another thing which is a good, like important learning or the goal of the MOXIE instrument is how can we learn things from the learning of MOXIE and Mars. So there is a MOXIE twin on Earth. It's also known as the engineering model. So the idea is we have the engineering model here on Earth, and then whatever we learn, because on Mars we were limited by how many times we can operate, because again, like as I mentioned, the power constraint. right? All the other instruments had to operate as well. So, and the idea with the engineering model is whatever we are learning from MOXIE on Mars, like take that knowledge and then, build more experiments so that we can just run those experiments in a simulated Mars-like environment, here on Earth.
How can you simulate the Mars conditions on Earth though?
Yeah, so this instrument is placed inside a bell jar, and then the temperature and pressure of that surrounding, or the setup is kind of set up in a way that you have like the Mars like temperature and pressure.
Well, where are the labs at where all these pieces are being tested and put together?
Yes, so the MOXIE instrument, sorry, actually I should have mentioned this very earlier. So MOXIE instrument is led by MIT. MIT Aeroastro Department and Haystack Lab. So this entire instrument is right now, I think it's Haystack Lab in Westford. So this is where the engineering model is, and then when again, I'll come to that as well on operating. But the idea was basically like we operated the entire MOXIE instrument based on like people who were based on like MIT and Haystack Lab. So I quickly went over like how MOXIE works. I'm going to now move towards the operating MOXIE on Mars, but before that, I just want to like ask if there are any questions.
My big one would be based on the current situation here on planet Earth with an environmental collapse pretty much. Do you think it's justified in all this research and development being focused on Mars rather than trying to solve the problems here on our home planet?
Well, I think it's a question. I think maybe like there won't be a right answer to this question. I think if we are just asking in terms of explicitly for MOXIE, like right, for MOXIE, what we are doing is like making oxygen, right? So if your question is geared towards can we use MOXIE here on Earth? The answer could be yes, but again, I think it will be a lot cheaper to plant more trees than basically building MOXIE like instrument, because like this is right now it's a very small instrument. So if you have to make such instrument where you can kind of like put it here on Earth and which can kind of like produce oxygen continuously, it's going to be extremely costly. And the other thing we are forgetting is for MOXIE, the biggest plus point is on Mars, you have 98% carbon dioxide. Majority of the atmosphere is carbon dioxide, which we don't have here. So how are we going to get that in, I mean, like the environment here, which I think we should not, because when we are talking about 98% carbon dioxide, then it kind of changes everything on Earth. But now, if I go back to like your question again, like how justifiable it is to like spend all these money on space research than Earth, I think to that my personal answer is all of the space missions that have been happened so far, like not just the Mars 2020 mission, like Apollo and all the missions, the technology that have been developed for space had always some application here on Earth. So if you kind of think that way, that like we are also benefiting the humankind here on Earth, I think to me that's justifiable.
But the whole thing, mission of converting carbon dioxide into oxygen, which trees do, I guess, but that's a pretty important thing, right? And you're figuring out how to do it sort of synthetically, or I mean, on Mars, and this machine takes carbon dioxide, right?
Yeah.
Converts it to oxygen, kind of like taking seawater and converting it to drinking water. I mean, it's very expensive right now, right?
It's expensive, yeah.
So I think the premise was if you can create oxygen on Mars, you don't have to transport it from Earth to Mars.
That's correct.
So you're probably going to get into this, but how do you store enough oxygen on Mars to make a difference?
Yeah. So So with the MOXIE, as I mentioned, it was a technology demonstration. It was just to see if this technology of ISRU really works there on Mars. Storing oxygen was not part of this mission. So there was that's an active part of the research. So I worked with one of the PhD students who actually worked on the extensibility of MOXIE. And what he proposed was how can we kind of design an extensible MOXIE and we can store that. So one of the solutions he proposed in his research was you liquefy the oxygen and you store it. So let's say if we are sending humans to Mars and then we kind of decide to use the MOXIE-like technology, then the idea would be you would send this MOXIE-like instrument on Mars way ahead.
Right.
Before humans really launch from here. And then the instrument would be placed on Mars and then it would run 24/7 continuously, producing oxygen. And then we would liquefy the oxygen and we would store it somewhere, basically in a tanks, somewhere as in the tanks. And then by the time humans reach to Mars, we would have enough oxygen for them to come back. So because again, we would want that would be an essential part of that mission because we don't want to basically lose the crew because once they reach Mars and then let's say if there is no oxygen, then there is no coming back until that amount of oxygen is produced. So we would kind of, to answer your question, I think it's more of we would store it somewhere. But again, with the MOXIE instrument, what we did was we produced the instrument produced oxygen and then the remaining gases the remaining unreacted carbon dioxide. So when the reaction happened, it was oxygen and carbon monoxide. So the goal was to basically measure the purity, all the different things. So how much pure oxygen did we make? How much unreacted carbon dioxide got reacted? How much of carbon monoxide got produced? And then getting all the data and then basically again exhaling the gases out in the Martian atmosphere and then again because there is some little trace of oxygen as well on Mars, so the unreacted gases got combined with the other gases and again it eventually turned into carbon dioxide.
You may have already answered this question. I missed the very beginning. Doing this on Mars, rather than say trying it first and trying to do it on the moon, because you're talking 20 million miles, aren't you, or something? That's a great distance, and I was just curious, if you could do it, on the moon and sort of prove that it, works and everything.
Oh, well,
If you need it, just to get to Mars is, that's a big.
Yeah, you're right. So yeah, just getting to Mars is, compared to moon, it's a very longer trip. That I feel I think the moon already has other resources, which a lot of companies and the space organization NASA and other space organizations are working on to see how can we use the natural resources of moon to produce the building blocks of life. I don't know where oxygen stands on that part though, but I don't have a right answer to your question.
I assume the moon doesn't have anywhere near as much atmosphere and so.
Yeah, that's another thing. Yeah.
Oh, yeah, it doesn't have
Yeah.
no carbon dioxide.
Right.
Yeah.
Tom, did you have a question online as well? Did you want to come off mute? I know you had your hand up earlier.
No, I did, but
You're good.
it was already asked.
All right, great, thanks. I know I had asked Piyush when he was doing this down at the community center. So those of us of a certain age know about the soft drink MOXIE. Is there a relation? And he assured me actually that whoever got to name this thing is aware of that, and not only the soft drink, but kind of the connotation of someone's got the MOXIE to do something. Well, imagine figuring out how to make oxygen on Mars. You got to have MOXIE to do that.
That's really true. So that's how the name kind of that was the motivation of the name as well, and then it was of course an acronym, but that's the motivation, like it basically got motivated from the MOXIE, the drink. And in fact, when we were doing our first run, so we did like, I was managed to buy some MOXIE like drink on Amazon and then a few other people as well, so
Oh, that's great.
yeah. Okay, so maybe I'll move to operating MOXIE on Mars then. So, how did we really operate MOXIE on Mars? To answer that question, I will try to answer that question, and how did the rover really operated on Mars? So, a day basically, or on Mars is called as, one day is called as one sol, SOL. And one sol is approximately, or 1 day on Mars is approximately 30 minutes longer than that of Earth. But that longer just changes everything, because it's not like the day starting basically, let's say today the rover, and also that also depends on where the rover is and the time and everything. So as I mentioned, one Martian solar day is equals to one sol, and which is 24 hours, 39 minutes, and 35 seconds. This actually image is taken by the Curiosity rover, which is another rover which is still operating on Mars, Curiosity Mars Science Laboratory. So this is the sunset on Mars. So, so the way operations works is, so the rover is already on Mars, okay, and then it typically sleeps at night, and then it wakes up at the start of the sol, which is around the sunrise, sorry, the Earthrise. So whatever we wanted to send, the instruction, so rover has all these other instruments. So it has cameras, it has microphone, it has MOXIE instrument, and then it has a radar and all these other instruments. So whatever the scientist wanted to do, like in a day, everything was bundled in a file called a sequence. And it was kind of hard coded in the sense that, let's say you wanted, in the morning at 9 a.m., you wanted the rover to kind of drive 10 meters. And then after that, you wanted the rover to stop and take pictures. So it was all a sequence, the bundled file. So, so the bundle file was that contained everything that was needed for the next day. It was sent directly from Earth to Mars.
How many megabytes?
I think that depends. That depends on the size of the entire thing. Again, like for MOXIE, it used to be few megabytes because even for MOXIE, it was a sequence. So as I mentioned, so MOXIE had three main part: the compressor, the motor, and the SOXIE instrument. So when I mentioned one run, so one run of MOXIE was approximately 4 hours. So the idea was we would first start MOXIE, and then he would heat up the SOXIE instruments to up until 800 degrees Celsius. When that's done, then the compressor would start. And then when the compressor started, we wouldn't just start at like the higher speed. We would start at some lower speed and then gradually increase the speed. And that's when we started getting when we started the compressor, that's when the oxygen started producing. And again, like in case of the MOXIE instrument, the oxygen was really represented by the current because it is still a battery. So the flow of current represented the oxygen production. So all this thing was put in a sequence file that turn on MOXIE, then start SOXIE at this time. Then when you are up until 800 degrees Celsius, there are other like all the sensors which would measure the temperature. So all these sequence, it was a huge file. So the size of that file kind of changed whenever we did different runs. So for the entire rover, I don't know how much the size of the like how much the size of the bundle was, but I would believe it would be couple of megabytes because we are not just talking about MOXIE, we are talking about all the other instruments and all the other things which are planned for a day. Sometimes, let's say if there was a weekend, then the idea was we would send 2 days worth of instructions. And then we would get the data back on weekday. So in that case, the size of that bundle varied. So as the bundle was received by the rover, then the rover kind of carried out the sequence of activities commanded in the plant. So for instance, let's say in this case, the rover drove few meters. Then it has a robotic arm which has its own instruments. Then basically, let's say you found a rock and then, well, there is a rock. So you would analyze the rock, the rover would analyze the rock. Then there are different orbiters. So how did we get the data back? So there are different orbiters around Mars. So whenever we kind of knew when the orbiter would pass over with Perseverance rover. So in the afternoon, let's say if the orbiter is passing, like it's going to pass, then we would send whatever data it has collected so far to the orbiter, and then it will continue the again like the operations. So the orbiter recorded the rover data, and then it then relays it back to Earth. Then again, like the rover carries out the sequence of activities, like the next sequence of activities that were commanded at the plant. In the night, it would continue, but mostly it would basically the rover would sleep in a sense that it would recharge the batteries. Now, this part was really crucial for MOXIE because when I said MOXIE kind of needed much of the rover's power, so many of our runs, we basically did it during night times because rover is not doing anything. So what we would do is we would run MOXIE, and then as the next day starts, the battery will be again like recharged after the MOXIE run, and then the battery state will be same as what was left before the night.
A question about the battery, you said it was charged by nuclear?
Yeah.
Yeah, then why not solar? Usually you see in outer space, these huge solar panels. Is it because of the amount of sunlight that reaches Mars isn't enough?
There are multiple things to it. So there were 3 rovers earlier. So I'm going to give you like a long answer to that question. So
Sorry.
So there are 3 rovers before Mars Pathfinder, Spirit, and Opportunity. All these 3 rovers had solar panels. I think there are multiple reasons of not having a solar panel on this rover. Number one, it's because of the size. This rover is of bigger size than the Spirit and Opportunity, and so way bigger than the Pathfinder size. So Pathfinder rover was size of a briefcase. I think maybe a cabin size bag, I would say. Spirit and Opportunity was size of a golf cart size, both the rovers. This is of the size of a Mini Cooper, or I think Mini SUV.
The
It's-
minivan,
Yeah, no, not minivan, but I think Mini Cooper, I think, mini.
Yeah.
Oh.
This is huge.
I see.
Yeah, I mean, it's
that's big for
it's
a
extremely
rover.
huge. Yeah.
But is the MOXIE inside the rover?
Inside the rover,
I see.
MOXIE is inside the rover. If you really want to see how big this rover is, I think they have a full-scale model of this rover at Museum of Science. in Boston.
Yeah.
So, so this is huge. So one of the reason they did not put solar panel space up, it's because of the size. Now, since the size increased, the technology to land the rover also changed. So for the Spirit and Opportunity, the rover, they could basically fold the solar panels. Another thing, so like one reason is the size of the rover, one is the amount of power required for the rover, because with the advanced rover, the number of instruments also increased, right? And if with the more amount of instruments, you would need more power. The other thing is Mars has dust storms. And one of the reasons, so when they planned the Spirit and Opportunity rovers, so Opportunity basically those were twin rovers. Those they landed in Mars. They landed on Mars in 2005. Opportunity, I think, still Opportunity worked until 2012 or 2013. Well, no, I take them back. It's even after that. The reason Opportunity stopped working because there was a huge dust storm, and then the entire solar panel was covered with the dust. So the idea when they sent the rover was, let's say if you have one dust storm, then the next dust storm kind of clear the dust. So also when it gets extremely cold at night on Mars, so you really want to keep all the instruments which are inside the rover warm. So for that also you will need some power. So Opportunity stopped working because the dust was completely covered on the solar panel. It couldn't keep the instruments warm at night. So all my understanding is all these different things kind of led to the decision of not doing a solar panel on this rover. The previous rover, the Curiosity Mars Science Laboratory, even that is also powered by the sorry. I mean the radioactive source. So even that has a battery, but that is powered by radioactive source. So the idea is the radioactive element at it decays, it basically generates heat, and then that helps to recharge the battery.
So they have like a little nuclear power plant.
Yeah. There is a nuclear. There is a nuclear power plant in the back of the rover. So in fact, this part here, this one, which is kind of little placed at an angle, inclined, that is the nuclear power plant. Yeah.
That's it.
So again, like the next, whenever the next orbiter kind of scheduled to pass over the rover, then kind of rover wake up and like it wakes up and then again like sends the data back to Earth. So sending, so from the orbiter, once the orbiter gets the data, then it downlinks the data. I mean, basically, it relays it to the Earth, and here on Earth, we would. So once you get the data on Earth, then that the ground system here on Earth kind of processes the data and then it gives to the technical operations team to make the decision. So how did it look like to kind of operate a rover on Mars in the perspective of the operations team? So I also got the chance to operate MOXIE on Mars. I was working, so within the MOXIE team, we had main two roles. One is the uplink lead and the downlink team, downlink lead. So uplink lead was responsible for validating the sequences and then the sending, basically giving the sequences. So again, so MOXIE is just one of the instrument on the Mars. So the entire Mars 2020 operations team, it was a huge, it was a big team where there were representatives of different instruments and then the rover and all the subsystems of the rover. So we would kind of send the uplink, like the person who was doing the uplink lead. He would like they would basically send the final bundle of MOXIE to the actual to the team who is actually managing the entire rover's uplink part. And the downlink lead was responsible for getting the data from the rover, basically from Mars, and then analyzing it and then making a decision of go, no go. That whether whatever you wanted to run on Mars on MOXIE, did it run? And then number two, it's if the instrument is really safe. I mean, like if basically making sure that nothing is broken, to put it that way. So once the team kind of reviewed, got the data from now in this case, yesterday is yesterday, it's kind of yesterday because in the context of Mars. So once you get the data, then kind of based on that, the team plan at a kind of high level plan for the next few days, what are the science things they want to do in the coming few days. So once the data that the rover sent has relayed by the orbiter, and then it is received by at the DSN. So DSN stands for Deep Space Network. So these are the collection of antennas around the globe, which kind of communicates with the rover. So once the data is received by the Deep Space Network, then it was sent to the JPL ground data system. And then the ground data system processes the information, the data, and then it clears, basically does some cleanup, and then it gives the data to the different instrument teams. So in the downlink assessment, once the team assesses the instrument and the rover health and safety status, and then kind of produces technical science data product. So in a simpler term, whenever we ran MOXIE, once we got the data, we had three main things. So it was all very time constrained. So we had to receive the data and then make a decision within just a couple of hours. If number one, if the highest priority was if the MOXIE instrument is still alive. Alive in a sense that if nothing kind of broke in it, no error occurred, or it's kind of, let's say, if you want to just run it next day, can you do that? That was the whole point.
What is a time that it takes the messages to get from orbiter down to Earth? I mean, is that?
Yeah, so the
messages travel, how many?
So that depends. So that's the around 10 to 15 minutes. It's the time it takes from Earth to Mars to
A few minutes?
yeah. So as I was saying, so for MOXIE, it was making sure that the instrument is green and it's healthy. And the next part of the assessment was whatever we wanted to do with that experiment with one run, did we achieve that? So to give you like in an example, whenever we did the first oxygen run, so what we analyzed was number one is MOXIE run successfully or not. If after running it's still healthy. And number two, did we really make oxygen? Because that was the whole goal of the instrument. So that was the preliminary assessment we did. But then after that, it was a whole lot of assessment later on offline, because now we had the data and then we would want to see. Whenever we ran MOXIE, we just did not send the instructions directly to MOXIE on Mars. We had the software models. We had the simulations. So let's say you wanted to run oxygen on Mars. So first you would decide, you would basically draft a sequence. The one I was mentioning earlier, that you start MOXIE and then heat up and then start the compressor and then kind of do all that thing. So once you have that sequence, you basically run that sequence over a software model. It's a simulation. It's kind of I would say, you can kind of say that it's a twin of the actual hardware, MOXIE hardware. We would simulate and make sure that nothing kind of errors there, nothing kind of, you don't kind of abort the instrument there. Make sure that basically whatever you are thinking, it kind of works there. After that, we would also run the sequence on a test bed, a rover test bed. After that, once you all have all these things like check mark, like all green, then you would send the instructions to rover. to MOXIE and Mars. So once we got the data back, another thing we wanted to do is whatever we thought, if the data kind of matches to whatever we simulated here on Earth, and then if it was different, then what caused it to be different and what can we learn? So that was part of like the broader assessment or like the research from the data whatever we got from MOXIE. So
Excuse me, I just have to go, keep going here, this is fascinating.
then the team reviewed the data and then decide what the rover should do when it wakes up tomorrow. And then this was called as activity planning. And this is how the sequence looked like. So you have different instructions that at 9 a.m. do this, then 10 a.m. do this, then you would have the camera, and then basically some of the things would work in parallel. So this is kind of a snapshot of the sequence.
Thanks, Pat.
Thank you.
Yeah, thank you. Really fascinating.
Piyush, how big was the team? How many people were doing this kind of on a daily basis?
In the MOXIE team or in the overall Mars 2020 team?
In the MOXIE team?
So in the MOXIE team, we were a team of 10 to 15 people. Like we used to take like the rover operations for the 90 days. It would we would kind of work over the weekends as well. And then so few of them were people only working on the uplink side, me and like other people who were only working on the downlink side. Then some of us would run the simulation, some of us would kind of create the sequence plan of like how do we want to kind of design that experiment, what do we want to really achieve. So overall it was a team of 10 to 15 people in the MOXIE team.
And just personally, did this all happen before you started working for MathWorks, or did you have to take a leave of absence to be able to have the time to do this, or how did that part work?
So this all happened after I started working at MathWorks. So I started working I graduated in 2014. I started my full-time job at MathWorks in 2015. I started working with the MOXIE project in 2017. Again, like I was doing volunteering. So basically working. So I worked for MOXIE instrument for MOXIE project for 7 years. So all those 7 years I was volunteering. I was doing it in my free time. So so yes, like for sometimes in the operations, I took off from work. I took a leave. The another thing which kind of worked in favor of me for the operations was for the starting 90 days or so, 3 months or so, the entire operations team used to work Mars time. So before COVID, again, like COVID happened, so everyone was basically working remotely. But that also kind of worked for me personally because it was remote, so I didn't have to go anywhere. Otherwise, for previous Mars missions, the way it worked earlier was, or the way it was set up earlier was for the first few months, the entire team would kind of relocate to JPL, and then they would work with like everyone would basically relocate to JPL in California, Pasadena, California, and then you would work as a team and then get to know people, and then and then after that you come back to your actual places. So when I said like the way it worked for me was, number one, because it was remote, so no one had to go anywhere. We were literally operating the instrument from our home, to put it that way. Number two, when it was Mars time, so many times the shift basically started in the night. So because and those who are actually living the Mars time, Well, I basically live both Earth and Mars time. Because-
Never slept at all.
Yeah, so there were few days, and then I used to take like shifts just over the weekends. Uh, Again, like my thanks to my wonderful wife, because she kind of supported me. Because the weekend shift was you would basically the night shift was you would the entire all the meetings, everything happened during the night. So people who were actually doing the Mars time or only doing the Mars time, they slept during the morning and then their day started in the night. So when I said how it worked for me, because I had a day job, so it worked for me in the day job, and then I would just wake up in the night and kind of took the shift. It was exhaustive. It was extremely exhaustive, but that's what I wanted to do for all these years. So for me, it was a dream come true.
That's amazing. And I think you also told us that, or when we were there in person, the software doing all of this, or at least your piece of it, is a MATLAB product. Is that correct? Or
Yeah.
MathWorks product, right?
Yeah. So the entire the MOXIE instrument, again, like uh, I worked at MathWorks, like I've been working at MathWorks, but the entire software model of this the MOXIE instrument, it was even like before I joined the team, it was designed in Simulink. So that is like one of our product at MathWorks. So, and then all the data analyses and everything, like the tool, we used like MATLAB heavily for that.
Well, I've got a question kind of pivoting away from Mars back to our local community and MathWorks, which everything I've heard about MathWorks is nothing but praise. And I really like them being on the lake and everything that they've done with their volunteer work. And what do you think would the chances of be that MathWorks might take up a cause like water quality in Lake Cochituate and say, there's some opportunities here to create or correct these problems, dealing with sonic and aeration. They're basic stuff that just has to be a little more developed to be really impactful, I think. And Massachusetts as a state, I think, is trying to pivot towards environmental remedial actions as part of its major economy effort. Do you think MathWorks might ever envision something like that right there on the lake, saying, look what we've done, look how improved this is?
Oh, well, first, thank you so much for like the good word of the math, like being good words about MathWorks. I completely agree. Like MathWorks is a great employer, like not just employer, but like doing a lot great stuff for the community. Being I think here in Natick for a really long time. I I think I'm not the right person to comment on your question, but I know that there are a lot of efforts going on for the climate, for the community. I'd love to connect you to someone who can like would be the right person to answer your question. But yeah,
Great, thank you. I think it would be,
Yeah. Sarah, did you have something?
Oh, I just wanted to, so I spent my career in hazardous waste site cleanup and water quality. And I think that, you know, I totally agree. I've heard fabulous things always about MathWorks. I do just want to stress that it wouldn't be MathWorks alone. It would have to be a very broad community effort because it's a very broad problem. But anyway, just wanted to weigh in with that.
Nothing's easy.
No, yeah, good answer though, Piyush. You know, separately, maybe we can connect in terms of who the folks at MathWorks are that help the company be involved in community efforts.
Yeah.
You know, that those would be the people to connect with. Pat probably knows who they are, because I know they help a lot on some of his cleanups.
Yeah.
But continue with your presentation. So, yeah.
Yeah, so then once that was like the snapshot of the sequence, so once the target and other settings or observations were finalized, everyone kind of collaborated with the planners, and then we kind of at the end we had the uplink product. So again, was not just the MOXIE instrument, but it had the sequences from all the other instruments over the about the rover. It got validated, reviewed, and then the team approves the result of day's work for go. So everyone would say like it's go, go. And like that exactly that was the word we used, like go for basically go. We are all clear. So the bundle file, which contained everything needed for the next source plan, is sent directly to the rover from Earth. So one thing here was, it was sent directly to rover from the Earth. So this I already like spoke a little bit. So the Mars operation, we for almost like 2 or 3 months we were living the Mars time. So the day is approximately 30 minutes longer, 35 minutes longer. So let's say on day 1, the operation started at 8 a.m. So the next day it would start at 8:40 a.m. Then the next day it would start plus 30 and so on. So some days started at the middle of the night. So it kind of changed like everyone's like the circadian cycle as well, because I mean, we did not really the entire operation. It was set for a week that the operations would start at this time, and then the entire operation shift was approximately 8 hours. So it was a very long, exhaustive. It used to be a long, exhaustive shift. So now I'm going to jump on some of the MOXIE runs we did. So this was the one I shared earlier. This is the screenshot of the chart of the first ever oxygen on Mars. So it was done on Sol 6 at this at the Mars time of 2 a.m. 25 minutes and 49 seconds on April 20th, and we made 6 grams per hour of oxygen. So as I was mentioning earlier, so the sequence was you start the MOXIE, you heat up, and then you start compressor, and then you produce oxygen, right? So this was how it looked like. So you would start the compress, you would heat up for approximately 33 hours. And then once the temperature has reached 800 degrees Celsius, then the compressor would start and it would start collecting oxygen, so carbon dioxide, and then would produce oxygen. And then after some time, it would end. And after some time, in a sense that was also hard coded that when to stop the compressor. So this was just our first run. In total, we did 16 runs. The goal was to do 10 runs in 1 Martian year. So we did 16 runs. We produced around 122 grams of oxygen. Again, like we never stored this oxygen. And again, this was the cumulative sum of oxygen we made. Approximately 1200 total minutes of the run. And then on an average, we made 6 grams per hour of oxygen. Now, many of the runs, the idea, the goal was not just run the MOXIE instrument and just produce oxygen and get done. The goal was to learn all these different things. So some of the runs we did at night, some of the runs we did in day, because in night and day, the atmospheric condition changes. We also wanted to run it during, let's say, dust storm, like when there was a storm, because again, when you would have a full scale, full size version of MOXIE, the instrument is not just going to run some time of the day, it has to run 24/7. So the idea was to see how it operates, how to basically operate the instrument, because whenever we did like the run, so the compressor, let's say we also wanted to try the limit of how can we like up to higher point we can kind of increase the compressor speed, how much more oxygen we can we make. So for instance, in the last run, this one, so we made approximately 8.1 grams per hour of oxygen. So it was also to kind of test the limit of the system. One more thing, uh, well, I'm going to ask you, this audience, a question. So I've started this presentation with the sound of compressor on Mars. How did we record it?
Data stream, just coming onto a chip and then downloading it.
Well, not really, but slightly close. So there is a microphone on the rover. Well, there are multiple microphones on the rover. So one of the microphone, which is on the mast of the rover. So what we did was, whenever we ran MOXIE, we literally like pointed the mast towards MOXIE. So whenever the compressor sound, that's how we recorded the sound of the compressor. It's also for outreach because, like when you see something, I mean, like I've given this similar talk at other places as well, like Framingham State University, they do the science on state trees even. It kind of really like it just creates that wow effect that, oh, this is how the compressor sounds on Mars. And there are all other recordings as well, like the sound of the helicopter and then the rover driving and all those things. So that's how we recorded the MOXIE compressor.
That's raises an interesting question, which you never thought of. Sound, I believe, does not go through a vacuum; it has to go through atmosphere. So the
Yeah.
Mars atmosphere is equally good as the Earth atmosphere for transmitting sound.
It's not identical, but it's kind of it's good enough to kind of transmit that audio. Yeah, and that was one of the other kind of research goal was to understand like how like there are other teams who kind of build that microphone, and then they are kind of also researching on exactly like the variation of how sound transmit here on Earth versus sound transmit here on Mars, there on Mars.
So did you say you did not store the oxygen?
Yes,
So you would create it, test it, measure it, and then release it?
yes. So this FMOC24 FM basically stands for the flight model, and then we had EM, which is the engineering model that was on part. So this was our last run. And we were honored with this group achievement award for the entire MOXIE science and operations team for demonstration of ISRU on another planet, for the exceptional operation of MOXIE instrument on Perseverance rover. Again, like this step is a very crucial step because it kind of paves the way of future human exploration on Mars, that we can really make oxygen on Mars. And with that, that's the end of the slides, and we have like approximately 20 minutes, so I'd love to take any questions. Yes.
You can probably stop the sharing now.
Okay. Yeah.
See everybody.
You talked about, at the very end, you talked about scaling. I'm just thinking, how do you generate that much oxygen over a period of time? And do you have any sense of how they're scaling it, or what kind of scale they would need? I mean, how big would this machine have to be to create enough oxygen and store it?
Yeah, so that's again like part of an ongoing research. So the company that built the cells, so SOXY, it's kind of a battery. Okay, so it has cells in it. So the company which manufactured SOXY, they are working on researching on how to actually scale up those cells for an extensible MOXIE. The research I contributed to that also was geared towards scaling, because this is just a small version. How would you scale, and how much do you scale to make enough oxygen for which could run 24/7? It also kind of considered redundancy, because this is again like this is just a demonstration, right? We did not want it to break, but let's say if it would have broken. I mean, that's fine in a sense that there is no loss of human involved there. But when you're really sending people to Mars, you cannot just risk on just breaking that instrument just because one of the things stopped working, right? So you would need to include redundancy in the system. How much, there are so many sensors in it, there are so many other parts like compressor, all the other parts. Let's say if the compressor just stopped working, what would you do? So all these things kind of factored, kind of a major factor on exactly the question you asked about scaling. And again, uh, it's an ongoing research, and yeah, it's an ongoing
Thank you.
research.
In terms of the scaling of it, have they decided that it would make more sense to have one very large unit as opposed to, say, 5 or 10 medium-sized units? I'm thinking of this issue of what if a compressor fails? If you only have one compressor and one unit, you're kind of done. But if you've got, you've lost 15% of your units, you still got something.
Yeah, that's true. So that also is part of that the research, that if you kind of make like one big unit or multiple unit, but I think that also depends on the launch vehicle, because if you are making a one big unit, can you transport that one big unit from Earth to Mars?
Mhm.
As opposed to you create multiple units, and then you kind of send those separately. So all these things kind of part of the logistics as well. So yes, they are all contribute to like the scaling. And
You had a slide earlier that showed a picture of the rover and all the other equipment that was on it besides the MOXIE unit. I mean, what you've described is complex enough, but do you have any sense of kind of how many other kinds of experiments or instrumentations there are on that device? I mean, as I say, as elaborate and complex as this has been, it's just a piece of all of the work that the rover's doing, right?
yeah, so many of the instruments are on outside of the rover. For instance, the camera, there is a radar, then there is there is a spectrometer, there is a microscope, there is a grill. So all those things are outside the rover. Inside of the rover mostly are the rover's computer. MOXIE instrument is another part of the like another instrument which is inside the rover. The sample caching system is also inside the rover. So sample caching system was itself is a different, like a huge beast in itself, because the idea was to collect the sample, put it in a tube, and then store it inside the rover until you find the spot where you really want to drop the instrument. So that's also kind of inside the rover. So it kind of a mix of what's inside versus what's outside. Uh, Another thing is whatever we learn from the MOXIE instruments, or not just from the MOXIE instrument, the entire rover, all of the data which rover has collected, it is publicly available. Anyone can access the data. So for instance, for example, all of, for MOXIE in specific, the entire data of MOXIE instrument is, I'm gonna share it here.
Yeah, if you could put that in the link, that'll be great.
So it's here on PDS. This is where all of MOXIE's data is published. We used to publish it every, I think, 3 or 4 months. So all of the data, well, as I mentioned, MOXIE project has ended. So all of MOXIE's data until the last run has been published here. People use it for just exploring for scientific purpose, for scientific purposes, for research, and that's the goal. In general, if you click here, this page, well, I'll share this link as well. So this is the main landing page for accessing, the entire data of the Perseverance rover, and then from here you can navigate to different instruments.
It's really cool.
Nice.
Wow. I don't know if there's other immediate questions, but I just want to take the opportunity to thank you, Piyush, for coming this morning and spending the time with us. It's just fascinating. And I kind of like that. I think we all on this group love Natick, and another reason to love it is that there are researchers like you right in our hometown doing this kind of amazing stuff that's really going to it pushes the whole planet forward, I think.
Well, thank you so much, Doug, and everyone once again for having me. I think working on the MOXIE project, I'm extremely grateful for the opportunity. Like it's been honor to work alongside people who had worked on so many space missions. So the principal investigator of MOXIE is Dr. Michael Hecht. He's a researcher in MIT Haystack. He has worked on so many other Mars missions. The deputy principal of MOXIE instrument is former astronaut Dr. Jeffrey Hoffman. So he is a professor at MIT Aeroastro, and well, he was the one to kind of fix Hubble Space Telescope in space. So, and then all the other team members working on MOXIE, and it has been a just amazing experience working alongside everyone and learning so many things, and really getting to work on really operating something on Mars. So it has been a great experience.
Yeah. Thanks again.
Awesome.
So I think I will go ahead and stop the recording now. And let's see.